Hey everybody. So I had a couple people email me with questions about some of these additional examples that I posted on implicit differentiation. So I thought I'd go ahead and make a video explaining them. So we looked at implicit differentiation and what it means and how to do it in the previous video. So in this video, I just wanted to give you a couple examples of other ways that we can use this implicit differentiation. So in this first example, we're going to go back to a topic that we talked about earlier, which is finding the slope of a tangent line. Okay, so we have this equation, 3 times the quantity x squared plus y squared quantity squared is equal to 100 xy. What we're trying to do is find the slope of the tangent line at the point 3, 1. So anytime you're thinking tangent line, you should be thinking derivative. So we want to find the value of the derivative at that given point. So here's where our implicit differentiation comes into play. So I'm going to go ahead and start by taking the derivative with respect to x of both sides of this equation. Okay, so we took the derivative with respect to x of both sides of the equation. Okay, so now we're going to go ahead and take our derivative. Okay, so starting over here on the left-hand side, we have a composite function. So we're going to need to use our chain rule. So starting on the outside, this is just a basic power rule. So bring our 2 out front. 3 times 2 would give us a 6. And then times x squared plus y squared to the power of 1. But of course, we don't really need the 1 there. Okay, so then chain rule, so multiplying by the derivative of the inside function. So the derivative of x squared is just 2x, and then plus the derivative of y squared with respect to x is going to be 2y times dy dx. Okay, so that takes care of the left-hand side. Now we want to handle the right-hand side. All right, so the right-hand side, we have 100x times y. So this is going to have to be a product rule because we have the x times the y. Okay, so product rule, we're thinking first times the derivative of the second. So derivative of y is just 1, but then chain rule, so times dy dx. Okay, and then plus the second times derivative of the first. The derivative of 100x is just 100. Okay, so this piece right here, that was using chain rule. And then this over here, that was using product rule. Okay, so that's our derivative. Okay, that's all of our calculus. So everything from here on out is just algebra. We just need to simplify. Okay, all right, so I am going to go ahead and on the left-hand side, I'm going to multiply the 6 actually into the second factor right here. So I'm going to leave my x squared plus y squared out front. I'm going to put my 6 in the second factor. It doesn't really matter where you distribute it into. I just figured might as well stick it in there. So 12x plus 12y dy dx. Okay. All right, and then on the right-hand side, there's really not a whole lot we can do to simplify, so I'm just going to drop some of my parentheses. So 100x times dy dx plus 100y. Okay. All right, so now I want to go ahead and continue simplifying the left-hand side here. Okay, so if we think about this guy, we've basically have 2 binomials that are being multiplied together. So I'm going to go ahead and FOIL this. So we have an x squared times a 12x. Actually, changed my mind. Instead of foiling it, I'm going to go ahead and I'm going to leave this as is. I think this will be better for us, and just distribute to the whole factor. I think that'll be a little bit easier. So I'm just going to write this as 12x times the quantity x squared plus y squared, and then plus 12y dy dx times the quantity x squared plus y squared. So I distributed it, but left it to that whole factor x squared plus y squared, just because it doesn't really seem like it would be to our advantage necessarily to get it fully expanded out, since the goal is to solve for dy dx. We don't want too many terms with the dy dx in it. Okay, on the right hand side again, really nothing we can do over there. Let's copy that down. Okay, so now if we're trying to solve for dy dx, we want to get all of our dy dx's on one side of the equation and everything else on the other side of the equation. So I'm going to leave my 12y dy dx times the quantity x squared plus y squared on the left. And I'm going to subtract the 100 dy dx over to the left as well. Did I lose? I did. That was a 100x dy dx. 100x dy dx. Okay. All right, and then we have the 100y on the right, and I'm going to subtract over the 12x times the quantity x squared plus y squared. Okay, so then on the left-hand side, we can pull out the dy dx from both terms, which is going to give us a 12y times the quantity x squared plus y squared minus 100x. That's going to be equal to still 100y minus 12x times the quantity x squared plus y squared. Okay. All right, and then solving for dy dx, we just need to divide. So we'll have 100y minus 12x times the quantity x squared plus y squared divided by 12y times the quantity x squared plus y squared minus 100x. Okay, so the only thing left that we can do with this derivative would just be to simplify it a little bit, because every term is going to be divisible by 4. Right, 112 are both divisible by 4, so I'm just going to go ahead and reduce my fraction here. We're going to have 25y minus 3x times the quantity x squared plus y squared divided by 12y, 3y times the quantity x squared plus y squared minus 25x. Okay, so that is our derivative. Let me go ahead and just rewrite that here. Okay, so that's our derivative. Now remember, the actual question in this example was to find the slope of the tangent line at the point, I don't remember my point, at the point 3, 1. Find the slope of the tangent line at the point 3, 1. So we're looking at this point 3, 1, and we want to try and find the slope, which is just the value of the derivative at the given point. So we're just going to plug in our point now. So 25 times 1, right? Plugging in 1 for our y's, plugging in 3 for all of our x's, minus 3 times 3 times the quantity 3 squared plus 1 squared, all over 3 times 1 times the quantity 3 squared plus 1 squared minus 25 times 3. Okay. All right, and if you evaluate this, you will end up with 13 over 9. So that is our final answer. Okay. Now, This wasn't actually asked of us in this example, but if they had, say, asked us to find the equation of the tangent line, then just remember that you'd be thinking about your y equals mx plus b, plugging in your slope, and then using the 0.31 to solve for b. Okay, so just keep in mind that if you are asked to find the entire equation of the tangent line, then once you find the derivative and plug in your point to find the slope, then just think about your y equals mx plus b to continue on and find the entire equation. Okay. All right, guys, so that was just an example of finding the slope of a tangent line, including this implicit differentiation.